Hello everyone, it's me Javindra Paudel. Welcome to my YouTube channel. Today in this video, I am going to demonstrate or introduce the Midas Gen application, which is developed by Midas Soft. Among the various applications like Midas Gen, Midas Engine, Midas Civil, Midas CAD, Midas Breeze, Midas FEA etc. By Midas Soft. Midas Gen 2024 or Midas Gen application is particularly used for the analysis and design of the buildings for the typologies of steel as well as RCC and steel reinforced composite structure, and it is used for the design of all the structural elements like other finite element applications like SAP, types. It can also be used in the analysis and design of the structure as well as nonlinear analysis of the structure. So today I'm going to demonstrate or introduce the Midas Gen, and let me start with the screen. After installing the Midas Gen, what comes in the PC. At first, after we open this application Midas Gen, the start page appears here. For the registration process, we have to go for register the protection license. These things we can get after the purchase of this application and making a separate account on Midas IT. So I'll make a separate videos for how to install the trial version of Midas Gen. Uh, for now, let me start here. Let me go for new project. Yeah, this this is the Midas Gen working interface for the modeling and analyzing the structure. We see here the coordinate system. This U means user coordinate system, and this G means global coordinate systems. And before starting to model the structure, we have to take care of the units, what we are using for the analysis for the modeling case, and the units for the load, etc. For the force, there are separate options like kg, ton, newton, kilonewton, pound, kibs, and for the length, cm, meter, inch, and feet. So for now, I am selecting the kilonewton and meter unit for the modeling as well as the application of load in this model. Here is a tree menu, which is very easy for picking the specific tags. Like this is the menu, this is the table like structure table, result table, groups, works, reports, and seismic assignment, seismic force assignment or seismic analysis. And we see the menu here like view, structure, nodes or elements, properties, boundary, loads, analysis, result, pushover, design, seismic performance, any query related to this software, and finally the tools. And we see here are the various tools that can be used in the modeling as well as the analysis of the structure. We see in the right part also. And if we click or if we right click on the area where these tools are located, we see here a tree menu. The first one is the tree menu, text pane. We see the text pane here, and message window, status bar, selection, change mode, zoom pen. They are all ticked and placed in this horizontally and vertically. Also, another important or very useful feature in Midas Gen is this tool. Here we can see the top view here, top, and these four which are adjacent or which are on the edge to top line are the four elevations. So you can see for four directions from the four face of the buildings, and this arrow indicates the view for or perspective view or 3D view or isometric view from the four direction. Suppose if we make a grid, for example, let me make a grid. Let me go to line grid, go to add. Suppose the grid name is grid AA, and I can add 5 grid at the distance of 3 meter for each grid, equal distance. Let me click OK. Here we see that 5 grid means 0 to 15 meters, with the equal spacing of 3 meters. And similarly, let me add on Y, 4 at the rate 3, 4 grid lines at the rate of 3 meters center to center. Okay, let me add and let me click OK. We see the grid lines here. We can zoom in or zoom out with the help of this toolbar here. Besides this, here are lots of toolbar that can be used for very easy for the entire analysis, modeling and analysis phase. So for this, suppose this is 3D view, and if we click top, we can see the plan. And if we click on this part or this part, we see the elevation from the entire from the respective direction. But now we have only a grid line, so the elevation is not shown here. Only we can see the lines, and this is the tree view or perspective view from this direction. If we click on this direction, like this, and like this, so it is a very useful tool in the working interface, and it always appears here in the right top corner of the working interface. After this, let me go to the menu tab. In menu, we see view, structure, node, elements, properties, boundary, load, analysis, results, pushover, design, seismic performance, as well as query and tools. For the view tabs, we can see the dynamic view, the type of view, or zoom, or previous view, initial view, which are included in the dynamic view. The second one is render view, and the third one is select or unselect the structural elements or select previous. And the fourth one is the active, to see which elements or which groups or which structural elements are active or which are inactive. We can select and make active or inactive. Similarly, the grid or snaps, the coordinates are user coordinate systems and global coordinate system. We can switch either of them. The grids, either point grids or line grids, and snap, point snap, line snap, node, intersection, element, all through, etc. Similarly, another tab is display and window. We can add new window also, and the window tile. If we have multiple window or multiple window working in the same working interface, we can view by tile horizontally, tile vertically, or cascade type. So these are the uh, tools or commands in the view tab. And similarly, if you go to structure tab, first of all we have to select the type of structure. We see the structure type is 2D or XYZ, YZ, or XY plane. 2D structure, the mass control parameter, as well as the unit or value for gravity acceleration. We see here 9.806 meter per second square, because we set the unit of meter here. If we set the unit of mm, we can see that 9806 mm per meter square. Similarly, align the top of the beam section with the center line for display, or align the top of the slab with the center line for display. We can control all these things from the structure type. And these are the type of the structural elements, like base structure mean beam, column, arch, frame, cross, plates, or shell. And if we have to model a tower, we have to go for tower wizard. For example, the transmission tower can be modeled with the help of this tower wizard. Over here, there are tower legs. There is tower leg, tower body, tower arm. And if we go for the modeling, if you have to model the tank type, the cylindrical tank structure, the input parameter have to be inserted here, and the tank can be modeled as per the requirement. Likewise, the building wizard will create the story level and building generation, as well as ID generation of the wall. Similarly, coordinate system plan, dimensions, groups, and check structure or duplicate the element or some missing element, free edge, face, etc. can be checked in this check structure of structure tab. If we move into the node element, we can create the nodes, duplicate or the node we are using. All the translation, division, merge, etc., delete, mirror, scale can be done on this node element tab. And here we can go for create elements, because this is the element tab. So the element can be delete, transfer, transplaced, translated, or extruded, divide, merge, intersected, etc. Rotate, mirror can be done in this element tab. And this is the flat structure. We see the modeling. If we have to model the column capital, we have to define and assign the column capital, effective beams, and the column strip as drop panel, etc. in this tab. And we have to define the mesh by auto mesh. The options of map mesh or define domain or define subdomain in mesh tab. Similarly, the first option before creating the nodes or elements or structure is to define the properties of material as well as the structural element properties. For example, if we click this material tab, we have to define the material. Uh, we have to add, we can add. We'll discuss more detail about this material tab or element tab in the upcoming videos. For now, let me just introduce all the properties or all the element tabs which are in the properties or other menu sections. And we can change the properties as well as compressive strength, define the material as plastic material, also section properties, scale factor, thickness, etc., damping properties in this properties tab. And in likewise similarly in the boundary tab, we have to define the supports. For example, if we click here, deformation in all direction and rotation in all direction, it means it is a fixed support for the base, assigning at the base of the structure. For now, let me uncheck this. And if you have to model the point spring, surface spring, or pile spring support, or general spring for soil modeling, uh, and the link properties like elastic link, rigid link, general link for link elements, and release. Another important properties for the frame is beam in release. We have to assign a release in secondary beam as well in the case of modeling, end offset, and the plate in release, etc. This can be modeled or done in this release offset, and miscellaneous tags in this wizard. So these are the things that are incorporated in the boundary. And in the load tab, all the static load, dynamic load, element load, etc., they are assigned with the help of this load tab. Here we can see the type of the load. For example, this one is the static load, dynamic load, settlement load, temperature stress, construction stress analysis, load tables, heat of hydration, moving load, etc. in the load tab. And after that, we have to create the load cases. Either it's a dead load or it's a live loads or a lateral load, uh, or wind load, etc. in the load cases. And this is the structure load. It means the self weight of the structure or nodal load. Suppose we have to model, we have to import the water tank load on the top of the structure on the fourth column point or four node of the interface column, and we can go for from this nodal load. Similarly, we can see the wizard for lateral load application, which includes the wind load, wind pressure, seismic load, earth pressure, and beam load means the elemental load that come from the walls, infill masonry walls. There is a pressure load as well, and finally the last one is the initial force or miscellaneous force wizard. So in the load, we can see all the parameter related to the application of load cases, etc. Similarly, if we go to analysis phase or analysis tab, we can go for linear analysis or eigenvalue analysis, heat of hydration, nonlinear analysis. All the analysis can be done from the analysis phase. We can see the perform analysis after controlling the data for the analysis or importing in inserting the data or filling the data that required for the analysis. We can perform the analysis. Here is the analysis option. This is and perform analysis tab is here. It can perform the analysis, but before that the structure can be saved. Similarly, we can see the result, the load combination. The load combination, it can be possible only after the analysis. The making of load combination can be done only after the analysis of the structure. Unlike the ETAPs, we can define the load combination before the analysis as well, but in Midas, then the combination of load shall be made after the analysis has been completed. So if we look into the this result phase, this is the combination of load results. We can see the reactions, stress, displacement, deformation, and any forces diagram, shear force, bending moment, etc. This result tab, and this one is detailed. Like this is the mode shape. The model properties of the structure can be obtained with the help of this tab. And if we see the effect of any moving loads or the time history analysis and miscellaneous so on in the result phase. And this is the pushover tab. We can conduct the pushover analysis after the application of nonlinear gravity load and making the pushover load case. And after the result extraction and result checking, we can go for design of the structure based on the codes. These codes are related to steel structure. The first one is IS 800-2007 mean. It's a code based on IS code used for the design of steel structure. And this is the code used for the design. This is the IS 456 2000 means this IS code is for the design of RC structural elements. And these are the sections tab used for the design of section results, force or properties we can see uh, that may require for the design and so on. So similarly, seismic performance query and tools, they can be demonstrated later in the upcoming videos. So this is the overall introduction for Midas Gen, which is a very useful and very powerful software for the analysis and design of the building structure, either it's a steel or RCC or composite structure. In the upcoming videos, I will explain how to model the structure and how to analyze the structure in Midas Gen 2024. Till then, don't forget to subscribe my YouTube channel, keep watching, like, share, and comment in the videos. Thank you.